Morning.
Morning.
It's 7:30 for you, right?
8:30.
Oh, 8:30. Still early.
Yeah. Same for you, right? Same for you.
9:30, so
Oh, 9:30 for you.
bit better.
Yeah. Right. 3 minutes past, so let's get started. Welcome everybody to the July 31st SIG Multicluster call. And there wasn't anything on the agenda, but MJ just added a Kubernetes demo.
Yeah, we discussed last time that
Yeah, we
there was
did.
no APAC 1, so just to cover the gap.
Yeah. So unless anybody wants to highlight anything specific in the scrub, I suggest I'll just change the screen sharing settings. There we go. So over to you.
Okay, so we had a discussion about Kubernetes basically looking for basically new home, and there was we did a demo for the US hours SIG meeting, but this one kind of slipped through the cracks. So there was a discussion that people might want to see that similar demo basically. So let me maybe share a screen and see where it goes. Sharing desktop. Do you see my screen?
Yeah.
Okay, so let me bump it up a bit. So what do I have from the setup perspective? And I will basically cover two things. One is basically what we have as a reference architecture. And I think for reference architecture, this is not something where we need home, basically. We want to find home. What we're looking home is for more for this handshake process, which I'm gonna show. So I have a GKE cluster running, which has a Kubernetes compatible backend deployed. So that would be basically one of the reference implementations of the spec potentially. And I have another kind cluster, John, which doesn't have anything. So if I check CRDs, basically nothing. If I check pods, there is nothing there. So idea of the Kubein is how do we extend the CRD-based services in a software as a service manner to the external clusters. So the whole spec basically defines a behavior where one says, I want to bind a service from this service provider. I don't have DNS, so basically it's a IP address, which corresponds to the service of the compatible backend. So that would be any URL provider exposing. So you execute bind, it gives you authorized URL, which redirects you to your approved OADC. So basically shared trust domain. And I say, okay, I basically want to bind it, and it says this service provider has MongoDB as a service, and there is a 2 formats currently supported. Again, this is part of the schema, part of the spec. So I say I want CRD-based MongoDB bind. So basically that's okay, and we're getting back to our controller. So at this point, the binding process happening. So what's happening is we're deploying an agent, and there is now, if I check the clusters, there is now CRD installed, a single CRD representing the service binding, which says I use this kube config and I bound this schema. And what we see, the schema basically got pulled into the cluster. And this is part of the spec. Like, how do we execute this handshake? How do we establish this kubeconfig credentials? How do we sync objects into the cluster? So now as a user of something like this, I can basically start consuming MongoDB instances. And somebody's ringing my doors. It's the best timing ever. So I hope we're gonna just leave it things outdoor. So I basically got object created in my cluster, in the one where I just bound the service. And that cluster object gets synced back to the provider cluster. Just 1 second. So object gets translated, it gets its own namespace, names clashes, and that's it basically. So as a provider now, I got object in and I can patch it. Basically, I can, you see there is no status, nothing on a consumer side. On a provider side, let's update something. So as a provider, you say, oh, there's somebody wants to consume my service. Let's basically patch the status to running. So this happening on a provider side. And if I check it again on a consumer, I can see status updated. Means one could create a service where you send a request for database and you get back update the database with a secret reference where to connect to. So, and this is again part of the spec we're looking to define and agree is how do you ensure that provider only has access to what the claim, what the binding itself, the API service binding defined. In the future, we envision here to have be a permission model where it say like this provider has access only to this CRD, this name, and potentially some secret. So that's the high level, what it basically, how it looks like. So from the implementation's point of view, anybody can implement a backend as long as they comply to the handshake defined, like how do we do a handshake? Like same way how anybody can do OEDC as long as you comply to OEDC callbacks and schema, as long as you comply to define ways of authenticating and exchanging kubeconfig, one could basically become a backend. Same with a potentially connector agent. I didn't show that, but the kind cluster, the consumer cluster, gets a very slim agent deployed which pulls the configs. So just to finish this demo, it's why we felt that SIG-MC is a place for this potentially, because I think more importantly here is not the implementation itself, but the agreement of how to exchange the data, how the permission model looks like, how the syncing looks like. And the implementations is just anybody could become one. Hence, spec is basically the product here, the deliverable more than the implementation itself. And I think we are not clear in that before, because it's very hard to demo a spec, because people see code, people see something action, and it's like, oh, it's a project. Like, why are we trying to pull a project in? And I think the answer is it's just one of the ways to implement the current spec, basically. Cool. And with this, I open the floor for the questions. Is there any questions?
Right, go for it, Ty.
Yeah, thank you for the presentation. And I'm curious, so to your point, kind of what's a compelling, I guess, demo or example use of this to really motivate what seems to me very cool. And I do recognize the use in SIG-MC. Right now, I'm trying to fix a pull request I have to Karmata, for example, and being able to install, for example, a Karmata agent so that it is self-service, if you will, for the runtime teams that use my infrastructure. It seems like it could be a very compelling way to say, hey, I want to try to shift left, if you will, in kind of that DevOps mindset for my Kubernetes runtime team tenants to use my infrastructure and this Karmata as a service, but to be able to use kubebind so that they don't have to commit various things into their GitOps repo. It would be a nice, clean way to be able to maybe pull upstream resources. And I guess for them, potentially, they could hydrate their services, right? If they're a Flink as a service cluster, or if they're a Spark as a service cluster, it seems like they could, set up a vanilla Kubernetes infrastructure cluster, but then say, hey, I just need to pull down my Spark bits. And they may have their own packages, I'm not sure what to call it, but the kubebind service for how they want to deploy Spark, but it would be all their CRDs and all that packaged up so that they don't need some other deployment infrastructure. I think the biggest question is there a view for kubebind to be used in both an infrastructure as code kind of automated form, as well as a, hey, I'm maybe deving around and I just need, like the MongoDB example would be great on a kind cluster perhaps or something.
So the steps I showed in a demo, the kubebind command itself, what it does.
I think I lost you.
Yeah, same for me.
I can try to jump in as long as MJ is not around trying to answer that. So I think what MJ was trying to say was that the demo that he showed was going on a kind cluster. So I guess it makes sense to think about it that way, like because you have the agent on the cluster, like that doesn't necessarily have to be a direct open network between the two clusters you're connecting. You'd like the let's say bigger cluster, the cluster where you have your Kubernetes backend running that needs to be accessible from the, I guess, spokes. Yeah, if that connection works, like the agent will take over basically the like talking to the central cluster, and I guess that means that your cluster doesn't have to be accessible in any way. It can be a kind cluster on your machine.
Cool. I think one slight challenge, and this is probably just would help as I read Kubernetes documentation, is to wrap my head around, certainly at my company, we've got a lot of infrastructure to stand up various clusters, right? And we kind of think of, there was the term cattle not pets as virtual machines became very easy to deploy, right? We think of clusters as cattle not pets. So, right, I can stamp out clusters very easily, but that uses a lot of infrastructure we've built that's not standardized. And I'm trying to think with Kubernetes how simple, if you would, it would be for me to say, here's my cluster profile. These are all of the backend modules I want to install on this cluster, and kind of run through that without human interaction. And if that is the right layer for Kubernetes, or if Kubernetes is expected more as a developer tool, like with this example here with the kind cluster.
So I didn't hear the beginning of the question. Is the builder just cut my power to my home, so that's fun. Basically, I think if I got it right, yes and yes. Like, to the original question, can it be used as infrastructure as code, more like that? Yes. Just the tooling side is this is what I showed you, which is more as a developer flow, where one could define a YAML spec, establish the trust before, because the key point is establishing the trust, the handshake, the kubeconfig, basically. If you have that prior, nothing stops you to use it in a more production manner. And that would become something like your Spark team giving Spark as a service, your cluster team giving cluster as a service to anybody out there. So instead of building like centralized platforms, backstages, one can build decentralized one and basically build it in a bit different layer.
Very cool. And thank you, MJ. That makes sense. You were mentioning no IDC, for example, being able to be used. And now I got you what you mean by that. So very cool. Thank you. That's a powerful set of primitives available with Kubernetes. So thank you for demoing.
Actually, I have a question for this demo. So yeah, because I don't know how to raise my hand. So sorry to interrupt you. So for this project, is it only working for the multi-cluster, or actually it could be work on the single cluster? Basically, the consumer and the provider could be in the single cluster, and also the cluster itself could be multi-tenancy.
Current implementation, they have to be separate clusters. But that's where again, this is why we're looking for a community, looking for input and place where to put this, because technically it's implemented now that some primitives are being landed in a cluster in a way which we can conflict if the same cluster is consumer and provider. But if there is a clear need for that and the requirement, we can try to work towards decoupling this basically. But for now, it has to be how it says.
I see. Because from the feature itself, it sounds like more like an application layer, because one cluster is providing some services, and the consumer is want to build a connection and try to consume these services. So that's why I was asking whether it should be in multi-clusters, or actually it could be single clusters.
It could be. The current implementation is that, let's say you create in my example, MongoDB database named foo. Basically this and database object CRD is a cluster scope. on your consumer side. But to have it properly as a service, you might want to have some transformation. And one of the transformations could be convert cluster scoped to namespace scoped CRD when moving to the provider, meaning that now you would have many databases called foo or dev on a provider side in a different namespaces, where namespace represents a tenant, a consumer, and it gets moved back to the consumer cluster as a cluster scope. So there might be some transformation, and this is where the current limitation is. This transformation happening, if it's in a single cluster scope, there might be some challenges.
But with all of that being said, I think it's important to say, like, the idea was basically to extend CRDs beyond single clusters. So kind of the single cluster solution, I think, is CRDs, because it's like basically just extending that to be consumable from other clusters. But I guess on the same cluster, you could just use CRDs directly.
I see. So basically the main feature of the Kubebind is to expose the CRDs. Is my understanding correct? Not the service actually, just register the CRD or exploring the CRD from the consumer side.
CRDs and potentially related resources like CRD plus secret, CRD plus config map. The implementation of those details is like, it's not workloads related, meaning you would not, in a current shape, you would not be syncing that database pod to the consumer. The database workload runs on a provider side somewhere in a cloud, and you just sync back a connection string or like a secret how to connect to it. So it doesn't do workload management as such, where like we distribute workloads across clusters. Same way like in a cloud itself, like if you go to Google Cloud, you create a virtual machine, you get a SSH endpoint, and that's it, an IP address. You don't know where the machine is running. So this is the similar goal to make it for CRDs and Kubernetes ecosystem, where one could request a service, gets details of it, and where the service runs is abstracted from the user.
Okay, actually, I'm just thinking that we bring up this kind of idea before when we creating the class profiles about. I remember Cotton demoed something about how to register the service in the multi-cluster environments, something like very similar to this. So, but I forgot the details. So basically, we have some brief idea before about similar to this. Maybe if we so cause before the discussion was whether we should host this project. Now I think you are asking whether we should host the KEP, right? So basically you want to bring up some KEP or spec around this idea.
Sorry, the connection was a bit dropping.
Yeah, yeah, go ahead.
So I was asking that before. So you were asking whether we should host this project, but now the question is whether we should bring up some KEP. So which about whether how to register the service in the multi-cluster environments, right?
In a way, yes. It's more about spec and a protocol, less about code and a project itself. Because I think this was a bit of miscommunication on our end, as mentioned. Like it's hard to demo a protocol without showing how it's in action, and what you've seen is a protocol in action. But from even this discussion, I can already see that there is so many gaps in a current proposed spec, like how does it act in a single cluster? How do we extend permission modes and everything? And for this one, I think we basically it's a more about spec, less about code.
Yeah, I think part of the confusion also came because this was coming from the same people as multi-cluster runtime, and so it felt like a sort of, well, similar to that, hosting a project rather than hosting a KEP or a series of KEPs. But yeah, to go back to the question about Corentin's demo as well, registering clusters within a multi-cluster. So that's about the handling credentials in cluster profile. And it's similar to one aspect of kubebind, but slightly different. So the Corentin's demo was about storing secrets in the management cluster, essentially, so that clients can look up other clusters in the cluster set and know how to connect to them. So that can be workloads running on the management cluster or workloads running elsewhere if necessary. And this is in kubebind, you'd have as I understand it, you'd have a similar problem because you're trying to control access to services or to something. So I'll avoid using services because that suggests that there's a sort of service proxy, which isn't the case. But so there is some secret propagation. So you need to store something like a secret and maybe something similar to a kubeconfig. So that's similar to the cluster profile credentials, but slightly different, and it's just a subset of what kubebind does. Yeah, Clay.
Yeah, I think they actually do go hand in hand relatively well. This was my confusion with MJ's comment on OIDC, right? But for my example, right, with certainly different than a single cluster. You know, if I've got a very large set of clusters and some enterprise identity system, so that a cluster can get a secret. Right, I could use the credential provider that Corentin proposed to figure out what application to do that credential request, and be able to effectively mint a kubectl for kubebind. It sounds like. So I think they could go hand in hand in that regard. So I could have zero trust provisioning, if you will, of a brand new cluster, and then be able to hydrate it with a bunch of CRDs. The thing, and if I can maybe pull back two different topics, because like the one challenge I would see is in a single cluster, CRDs are cluster scoped. So I don't see multi-tenancy necessarily for kubebind making sense. I just wanted to kind of confirm that I was understanding right there. Maybe Kubernetes has some different behavior than I've appreciated.
Yeah, I think, yes, you're right. And this is why it's a more multi-cluster stuff, as you said, seeding CRDs, services. It's not about workloads as that. It's more, there is this full ecosystem of CRD only based services where people don't use pods, deployments, and everything. You create, this is why we chose database, because it's the best example. You don't need database itself running in a cluster. In most cases, in most organizations, database runs on a dedicated cluster, dedicated hardware. What you need is just connection string. And that's a very good example because you submit a claim, a request for database, and you get a connection string back. And that basically kubebind covers all this area of this basically domain, how to consume a CRD-based non-runnable workloads, let's call it like that. I don't know.
But it doesn't have to be a non-runnable, right? I mean, I could be hydrating, all of Argo for, Argo workflows with this, right? The controllers would have to still get installed somehow elsewise, right? Because you're only providing the CRDs.
Yes.
But that, so there's a level of inception there. Let me ponder on that. I have one last question, then I'll get caught back up to where we're at in the discussion here, which was you were saying that you are proposing this would become part of SIG multicluster as the embodiment of the code or the specification of how KubeBind works?
I think it's more about the latter one, the specification. Like what's the same as you have a like cluster profile. It's a definition of cluster. Same you would have a service definition. Maybe we need to find a different name, service which doesn't imply networking, like a service database service. Like how do you define permissions? How do you define which CRDs to pull in or schemas? How do you exchange a kubeconfig? And implementation itself, like if there is a place to host an example implementation, I think that would be appreciated. If not, like as I said, it's more spec and agreement on these exchanges, I think, is more important than the implementation itself.
Interesting. And I guess I very much really like specifications and defining them. And maybe it's, I'm in Denver, Colorado, so maybe it's just because it's late my time and I'm failing to envision, but here I'm super, and I know that SIG multicluster as a whole tends to focus on specs more than code embodiment when possible. But I'm super excited about the code here, and I'm actually failing to see the general applicability of the specs. And so I'm not sure if there's an answer needed on that, but I just want to point out that I'm actually the opposite, I think, of what you're proposing was my initial understanding and what would make sense to me. So just wanted to point that out. And I'm reading the code now to maybe see how spec could be pulled out, but I didn't see a strong specification necessarily defined in the repository that I was looking at.
No,
KubeBind/KubeBind.
There is not in the repository. There is a better, we did, I think, better job in a documentation in a kubebind.io.
Cool.
There is this like a flow charts, what the API export, API binding, API resource schema object looks like. So we've been working on this in a way, but yes, it could be a better job. But this is why we're here.
I hadn't looked at kubebind.io, so I'll look at that and wrap my head around it. Thank you very much, MG. Chen, my apologies.
Any other questions, discussions?
Chen had a hand up and unmuted, but Chen, we can't hear you.
No, nothing.
If Chen, Chen says, my bad, there must be something wrong with my equipment.
Yes, and I said there is a, just to finalize this, there is a running thread in a KubeBind's mailing list. Feel free to pitch your concerns or support for this in there, because I think we're looking for a closing the stopper sooner than later and seeing where we can move with this basically. And with this, if there is no other questions, I will have to drop off because the builder's problems keep continue.
I might just ask one last question for you, MJ. The SIG multicluster items like we brought up Corentin's cluster profile provider, credentials provider. Would there be interest, even if the spec goes to SIG multicluster, with trying to pull some of those features back into KubeBind? Would you expect?
I honestly am not that in-depth familiar with a cluster profile spec and all that stuff to basically be able to answer it now. If we need to pull things right or left, I don't see a problem with that. Like, it's basically we're operating in the same ecosystem, but to answer it fully, I don't have enough background.
That's perfectly fine, and I think I'll learn more about the project as I read. So thank you so much for the presentation. Good luck with the.
Right, well, if there aren't any other questions, so well, Chen's questions will go to the docs. That's fine. We can probably stop early. I won't be around for the next call in 2 weeks' time, but I'll leave it in the calendar so people can connect. The only caveat is that people won't be able to share their screens. And feel free to add topics to the agenda doc and take notes during the call, and I'll see you, I guess, in September.
Thank you very much.
Bye.
Thank you. Bye.